Many students are confused when it comes to electronegativity and electron affinity. So what's the difference between these? Let's clear that up for you. You'll see electronegativity more in chemistry. It's used in chemical bonding, polarity, seeing if a molecule's polar or how it reacts. But electron affinity, that comes up when you're studying periodic trends, atomic physics. It's useful for that, how ions form, maybe if an ion's a good oxidizing agent, being able to predict that. So it's useful as well, but this is the one you're going to see the most. So let's talk about electronegativity, then we'll talk about electron affinity, and we'll just do the comparison. This is really the key, though, to what you need to know. So the big deal with electronegativity, we're talking about the electrons that are shared in a chemical bond. So we're dealing with a chemical bond, usually covalent. And it's these electrons right here. If they were shared equally, it'd be right here in the middle. But this is water here. We have H2O, oxygen and hydrogens, and they're bonded here, sharing these electrons, pairs of electrons. Because oxygen is more electronegative, it can pull those shared electrons closer. And you can even see with the water molecule, this line, it's not right down the center. So these electrons, they spend more time with the oxygen, give it a partial negative charge. Electronegativity is dealing with the shared electrons in a chemical bond in a molecule. That's the key difference. If you want to understand why that happens, I have a video on that linked out at the end of this one. There aren't any units with electronegativity. It's a relative scale. Most often it's the Pauling scale. So let's look at that here on the periodic table. So fluorine is the most electronegative. So basically the Pauling scale said fluorine's the most and we compare everything to it. That's why we don't have units. As we go across, electronegativity increases. As we go up groups, any of these groups, it increases. So if you know fluorine's the most electronegative, everything else kind of goes towards fluorine there. We kind of ignore the noble gases. There are a few that bond, but in general, we don't really pay much attention to them. That's electronegativity. So chemical bond, pull on shared pair of electrons, no units, fluorine is the most. That's what you need to know. Electron affinity. So for electron affinity, we take a gas, an isolated atom like chlorine here. It's neutral and it's in the gas phase. And we add an electron. So these are the electrons. When we do that, what happens, it gains the electron and energy is released. And we can write it like this. Neutral atom in gaseous phase gains an electron. We get the anion, a little bit bigger. Anions are larger than neutral atoms. And some energy is given off. And we can actually measure that energy. We can do this in the lab, and it's in kilojoules per mole. So it's a real value. It has units. And the key is it's an isolated atom. It's neutral. It's gaining an electron. It's forming an ion. And that energy, that's how we measure electron affinity here. Let's look at that trend on the periodic table. So in general, as we go across periods, it increases. And in general, as we go up the groups, it increases. So in that sense, it's the same trend as electronegativity. But just because the trend is the same, it doesn't mean it's the same thing. They're very different. There are also a lot more exceptions with electron affinity here. Chlorine, that's the highest. It has the highest electron affinity. Note that electron affinity has a negative sign in front of it. That's a thermodynamic convention. So fluorine is negative 328. Chlorine is negative 348. We say it has a higher electron affinity. So same trend with more exceptions for electron affinity, but very different ideas. So that's it. Probably the big thing to realize is with electronegativity, we're dealing with this shared pair of electrons. It's pulled more towards the electronegative, the more electronegative atom. When we're talking about electron affinity here, we're talking about an atom that's gaining an electron. A neutral atom gains an electron, and there's some energy involved. And that tells us about the atom and the ion formation. That's it. If you have questions, drop them in the comments. This is Dr. B taking a look at the difference between electronegativity and electron affinity. Thanks for watching.